For anyone that doesn't recognize this machine, this is my Centurion Minicomputer. It's a big, serious business machine from the 1980s, and it has an incredibly unique CPU in it. It's made out of AM2901 bit slice ALUs and a boatload of 7400 series logic to create an instruction set that is not shared with any other CPU on the planet. It is specialized to this machine. But that CPU can do context switching or task switching incredibly fast, which means that this thing can have up to 32 simultaneous users on a single CPU. It also has 256K of RAM and currently 2 CDC Hawk drives providing 10 megabytes each, a CDC Finch drive that gives 32 megabytes, and a CDC Phoenix drive that also gives 32 megabytes, but that Phoenix drive is currently crashed. That's something that we need to get to in the future. And rounding out the peripherals, we have this beautiful ODEC Data 100 line printer that can do 125 lines per minute. This is one of my all-time favorite machines, but because of that unique CPU and the incredibly unique operating system that works with it, writing software for this thing is a bit of a challenge. Now, of course, if you want to extract the most amount of performance out of this machine, like any other machine out there, you're gonna have to write in assembly. And I have written assembly for this thing before, and oh boy, it is not easy. I am bad at assembly, but also this is kind of an obtuse CPU to write assembly for. But naturally, Centurion didn't expect software developers and dealers and whatnot to write everything in raw assembly. So they created their own programming language called CPL, or Centurion Programming Language. And this is actually a pretty nice programming language to use. It's a little reminiscent of COBOL, although not entirely. I've tried to dabble in COBOL and it completely mystifies me, but I can sit down and write in CPL pretty easily. But if your only two options for programming are either assembly or a programming language that's proprietary and nobody's ever really heard of, you're gonna get a ton of software developers complaining, begging for something that's a little more approachable and user-friendly. And that's exactly what happened to Centurion. They got a ton of complaints and requests to have BASIC on this Minicomputer. And so grudgingly, they got to work porting BASIC over, and it is awful. It is a terrible port of BASIC. So let's write something for it. There's an interesting field within mathematics and computer engineering called cellular automata. Essentially, you have a grid of cells, and each cell has a finite state. It can be alive or dead, for example. And the fate of that cell is dependent upon the state of that cell's surrounding neighbors. This was originally conceived in the 1940s by Stanislaw Ulam, I think I'm pronouncing that correctly, and John von Neumann. But in the 1970s, a brilliant mathematician by the name of John Conway came up with Conway's Game of Life, which is a cellular automata, and it has become one of my all-time favorite programs. I like to run it on anything that I can. So John Conway's Game of Life, each cell on the grid has 8 neighbors. If a cell is currently alive and it has less than 2 neighbors alive, that cell dies as if by underpopulation. If a cell is currently alive and it has more than 3 neighbors that are alive, that cell dies as if by overpopulation. The only way that cell gets to live on to the next generation is if it has exactly 2 or exactly 3 neighbors that are alive. If a cell is dead and it has exactly 3 neighbors that are alive, that cell is born again in the next generation. And that's it. That simple rule set alone creates an unbelievable amount of complexity that simulates life, cellular life. It grows, it dies, it evolves, it changes every generation. And Conway's Game of Life is really fascinating because it's also Turing complete. You can create flip-flops and adders and all of the necessary building blocks to make a computer. So you can compute anything under the sun as long as you're patient enough for the little cells to move in the correct way to do it. But there is one massive problem with Conway's Game of Life, and that is that it requires an XY grid. This isn't a problem if your computer has a CRT with cursor controls, like the Centurion. So we could totally program Conway's Game of Life for the Centurion, but not all of the computers in this room have a CRT with cursor controls. Notably, the LGP21 and the Bendix G15 use printing terminals, as does the TI-980, which is ultimately going to use an ASR33, which, I mean, the ASR33 was kind of like the go-to terminal for computing for decades. So it would be really nice if we could come up with a version of Life that could be used on a terminal that doesn't have any cursor controls at all. And so the obvious solution here is to go one-dimensional. And that leads us straight into another brilliant mathematician, Stephen Wolfram. Wolfram came up with a version of Life that only looks at the neighbor directly to the left and directly to the right of a given cell. And since there's only 3 cells in question at any given time, that comes out to a total of 8 different combinations. And then we can list what each state will become in the next generation by just listing it as a 0 or a 1. If we list the results out as 0, 1, 1, 1, 1, 0, 0, 0, this 8-bit binary number is 30 in decimal. So if we follow along with this specific rule set, Rule 30 here, we get a very interesting geometric pattern that grows in a beautiful way. And there's 256 different rule sets that we can use with this particular design of Life. And some of them are really fascinating and some of them are really boring, but going through each one is kind of interesting because you can see how such a simple concept can create such diverse complexity. But if I'm being honest, Wolfram's 1D Life here feels a little too predictable. The patterns are just a little too recognizable. It doesn't feel messy like real cellular life would, like John Conway's Game of Life does. So is there a 1D version of Life out there that does capture this messiness of cellular life? Well, Jon Millen asked this question and came up with a brilliant answer. You just look at the 2 neighbors to the left and the 2 neighbors to the right. So you're looking at 4 neighbors in total to decide the fate of the cell in question. And this creates an incredible amount of complexity. Now, of course, you can change the rule set however you want, but the rule set that Jon Millen proposes is that a cell that is currently alive and has exactly 2 or exactly 4 live neighbors lives on to the next generation. A cell that is currently alive with exactly 1 or exactly 3 live neighbors dies before the next generation. And conversely, if a cell is currently dead and it has exactly 2 or 3 live neighbors, it is born again. And that's it. That simple rule set creates a phenomenal amount of complexity. And because it's one-dimensional, we can run it on any machine in this room. We actually got it programmed for the LGP21, a fully transistorized computer from 1963. And I think that's the oldest computer anywhere in the world to run a version of Life. And it will probably continue to hold that title until we get it running on a Bendix G15, which would move that all the way back into the 1950s on a vacuum tube computer. But I wanted to have 1D Life running on the LGP21 for VCF Southwest, and it was awesome. But my good buddy AJ over at Forgotten Machines also wanted to have Jon Millen's 1D Life running on something at VCF Southwest because our tables were going to be right next to each other. And so late night, I got to work knocking up a version of 1D Life in single user BASIC for a Data General Nova 1210. It's a pretty short program, and I went to extra lengths to make sure that it didn't rely on anything that may not be present in various versions of BASIC. So the first thing we got to point out is that it absolutely must have line numbers. Some versions of BASIC can get by without needing line numbers, like Quick Basic, for example, but we want this to be as compatible with as many versions of BASIC as possible, so line numbers have to be in there. The next thing is that I don't have any subroutines. So everything is a go-to line number. There's a couple other quirks here. If you do an if-then statement, the resulting then has to be a go-to. So if some conditional, then go to this line. You can't do if some conditional, then count equals count plus 1 or anything like that. Not doable in single user basic. Single user basic is very bare bones and actually feels a little bit like programming in assembly here. So we start off right at the top with dimensioning an X and a Y array. The X array is the current generation, the Y array is the next generation. Then we step through that array one value at a time, generating a random number for each one and filling that value with either a 0 or a 1. And then we step through that full array again, printing it out on the screen so that we have our base randomized seed at the very beginning. Then we start a for loop from 0 to 25. Now the reason that we're choosing just 25 generations here is that in our experience, Jon Millen's 1D game of life here starts to hit some form of stability after about 25 generations. So we slap a new random seed in it after 25 generations and delve back into the chaos. After that, we start stepping through the array and we jump down to line 500. All we're doing on this is creating a small little loop that counts the neighbors and adds whether that neighbor is alive or dead to a running total. And then we check if the current cell is dead, and if it is, we jump down to line 800, or if it's alive, we continue down to line 700. And then in here, we simply kill the cell right off the bat. Then we check to see if it's 2 or 4, and if it is, we bring that cell back to life. And then that's it. Really, that's all there is to it. It's a very short, simple program, and it runs on pretty much every basic we've thrown it at so far, with the exception of Centurion basic here. Now, I did a lot of testing of this in Meisaka's wonderful emulator, so if you want to play around with the Centurion, link in the description below on how to get to her emulator. But I did have to make a few changes. The first is that you can't dimension an array with a variable for the size. You have to actually type a number in for that size. And then the next problem is like a super hyper frustrating one, and I didn't really know a good way to get around it. Whenever you print out a value in BASIC, if you put a semicolon at the end of your print statement, it prints that value without printing a new line or a space. Except that in Centurion BASIC, for some reason, it does print a space. I cannot figure out any way at all in Centurion BASIC to print a value on the screen without also printing a single space after it. And that broke the entire output formatting, so I had to do some tricky shenanigans here. I had to insert a bunch of interesting cursor commands here to get it to print in order, and I think that's going to slow our program down quite a bit, but it means that the output formatting of it stays pretty absolute. However, aside from those two changes, the rest of the code is as it was on Data General Basic. So let's load this up on the Centurion and see how it runs. I've got the hawk drive spun up and we're sitting at the D equals prompt, so all I gotta do is type H1 and it's gonna do 3 RTZs and it should start loading in the initial program loader and then searching for and booting up the operating system. Right now, the only 2 disks that I have spun up are the one of the hawk drives and the Finch drive. So if I do a .sta, this is gonna be our status screen. We can see our total system RAM is 256K. The 2 drives here that are offline, that's the extra hawk drive that is not turned on at the moment. So I want to get my basic program running in the operating system here, but this is not like your average everyday home computer. I can't just get to a basic prompt. As a matter of fact, the basic programs are actually compiled. So we have to jump through a ton of hoops. The first is that even though the basic program is compiled, it doesn't actually compile it down to machine code. It goes to some kind of intermediate thing. So we have to load something called a basic monitor. And we do a .load space basic to do that. We don't get any feedback from that, so I just got to do a .sta again here. It's going to reload my screen, and then right here we can see it says basic monitor loaded. Now we have to get that basic program into an ASCII file on the disk so that we can then compile that ASCII file into something that we can execute. But normally you would have to do this by like typing new to create a new ASCII file and then opening that file in the built-in text editor called compose and then start writing it out with that. But Compose is an absolute nightmare to use, and we have a much better solution to all of this called CED, or Centurion Editor. This is a new piece of software that was written by the unbelievably brilliant Rin14500, and without a doubt, it's the single piece of software that I use the absolute most. It's really easy to use and works amazingly well. So we just do a .s.ced here, and we're gonna name it ZODL for one dimension life. Anytime you're writing source code into an ASCII file, you need to prepend it with a Z because the compilers look for that Z to be there. We're gonna put that onto disk 1, and then we want the CRT that I'm using to be CRT0. So we're just gonna go ahead and enter on that. It's gonna ask me if I wanna put it into a library, which is their version of folders. I don't, so I'm just gonna do a new line. It's gonna say ZODL does not exist. Do we wanna create it? So I'm gonna hit yes, it's gonna create it, and then we get to the CED prompt. Oh, we get a WP1. I gotta turn the write protect switch off on the, the drive to get to it. So there we go. Now we get to the CED prompt. And so I'm just gonna hit A for append. It's gonna say do a dot by itself to end, and now I just gotta type in my program. So we'll start with 5 here. So 5, LET for let, M space equals space 68. Go ahead and hit enter on that. All right, we got our first line in. I just need to do this for the next 9 million lines. I'm just kidding, I'm not gonna do that. There's a much faster, easier, better way to do this. This is a multi-user mini computer after all, so all I'm gonna do is pull my laptop out, plug in a USB to RS-232 serial cable, plug that into one of the spare serial ports on the Centurion, and then all I gotta do is, once I'm here at the prompt, just fire up Minicom and hit Control-C, and it says CRT2 ready. We're talking to the computer. I could do a .dir1 here, and I'll get a directory listing of everything that's on that drive. Now, before I go pasting the file in, I do have to adjust a little bit of the settings on Minicom here. So I'm gonna do a Control-A-Z, and then for terminal settings, I'm gonna hit T. And then you can see that we have a new line transmit delay and a character transmit delay. And I'm actually gonna bump that up to about 10 milliseconds. So I'm gonna do a D, and then we're gonna do a backspace 10, hit enter. And then I'm gonna do an F, backspace 10, hit enter. And then all we gotta do is hit escape. And we're back there. I hit escape too many times, and apparently if you hit escape in Minicom, it just types Minicom 2.9. Very strange. Okay, so let's do an s.ced ZODL on 1 for CRT0. Go ahead and enter on that. It's gonna ask me about the library. There isn't one. And then we're gonna get to the CED prompt here. And I'm gonna do actually a D for delete, and I'm going to tell it to start at 0 and finish at 999. Essentially, I had typed a few things in that previous shot, and I just want to go ahead and get rid of all those. So we have a completely blank slate here. So now I'm going to hit A for append. It says period by itself to end. I'm going to Alt-Tab over to my program here, and then do a Control-A, Control-C. And then we're going to Alt-Tab back over to the terminal here, and then I'm going to do a Control-Shift-V to just paste it, and we should see it start typing in all on its own for me. I don't know why it's so jittery, but it does look like everything is getting sent in correctly. This may just be a quirk of Minicom here. There we go. We got all the way down to 860, so I'm going to hit a period, hit enter, gets us back to the command. I'm going to hit a Q, CED done. It writes the file out for me. We're good to go. Now we just need to compile this into some kind of executable that the basic monitor can run. So to do that, we're going to do a p.basic of ODL. We're going to drop the Z because the compiler automatically prepends the Z for us. That's on disk 1, and we want our compiled status output to come to this laptop CRT, and that is CRT2. So I'm going to do a CRT2 here, and then we're going to add an extra little X on the end there to clear out any extra JCL statements. So we'll go ahead and hit enter on this. It's not in a library, so here we go. All right, so the well, there we go. 0 errors, 0 errors. Yeah, there we go. However, because I'm a bit of a purist, I want to see what it looks like on the real CRT. And now it's finally easy. We just do a .run space XODL. Hopefully this works. I'll go ahead and hit enter on that. Oh, there it goes. Oh, whew, that was an incredibly long wait. Oh, it's so slow. Oh, it's so slow. It's currently calculating the next generation, I think, but it's just... Oh man, this is like as slow. Either that or it's broken. One of the two. It looks like it got the... oh, nope, there it goes. Oh my gosh. That is terrifyingly slow. That is easily 4, 5, 10 times slower than the Data General Nova 1210 running BASIC. I mean, the basic interpretation on this is I knew it was bad, but I didn't think it was this bad. But it's working. It does seem like it's working. Whew, I was not expecting it to be that slow, though. Oh, man. In a sense, it feels a little bit like TI Basic on the TI 99.4 because we're going from basic code to some kind of intermediate level, and then we're interpreting again from that intermediate level down to something that the CPU can execute. But that doesn't mean that the Centurion's slow. I mean, we're well out of its wheelhouse. The thing was designed for really fast task switching, whereas this is pretty much like a single user thing that is hammering the CPU very hard, and the CPU is really only chugging along at 5 megahertz, but it should be way faster than this. Like what it comes down to is that BASIC was never really a serious endeavor for Centurion. It was just so they could tick a box on the marketing documents and they could shut up a couple of the dealers that really wanted a BASIC. If you wanted to do real deal software development on the Centurion, you did it in CPL, or Centurion Programming Language. And so I'm curious how much faster this program would be if somebody were to write it in CPL. Thankfully, that somebody is me. I nerd sniped myself with this last night at about 10 o'clock, and I hammered it out. I wrote it out in CPL, and actually, like, it was almost easier to write it in CPL than it was in BASIC. CPL is a really pretty good high-level programming language. All right, let's Control-C out of this just to break out of that program, and I've already copied the file over just like we did for the BASIC program there. So if we do like an s.crt z odl-cp on 1 for crt 0, it's not in a library, and yeah, there we go. There's all of the CPL code that I wrote in a fever dream last night. It's a lot longer than the basic version, but I mean, honestly, it was surprisingly easy to write. So now we got to compile it, and we do that in a very similar way. So we do p.cpl, and it's going to be odlcp. Remember, it automatically appends the z for us. It's going to be on 1. We want our output to be on crt 0, and we're just going to do an x to clear out any extra JCL statements. We'll go ahead and hit enter on that. It's not in a library, so here we go. We're off to the races. CCOMD, have no idea what that is, but it's running that on the file right now. Apparently it was happy with that. Now it's running p.xassm, so this is an assembler, and this I think is the important part because CPL is very close to the Centurion assembly language. So whenever you write a CPL program, it's essentially going straight to assembly really easily. Not only that, in the middle of a CPL program, you can type a command and drop into assembly directly and start writing assembly in the middle of your CPL program. I think it's the right way to program for the Centurion. It's a really nice programming language. We can see that it's going through all sorts of intensity here, but there's been no errors so far, which is pretty good. It just ran the linker to link it to an executable, and there we go. So if I do a .run xodlcp, I haven't actually run this on the real hardware yet. Let's give this a shot. Look how much faster it is. Oh man. Oh, that's awesome. It is. Oh, it's like lightning fast. Night and day difference between this and the basic. That's really cool. Oh, and the one-dimensional life is running great. You can see we did our 25 generations there, and then we loaded up a brand new random string. My random number generator in this CPL file is not good because as much as I like CPL, it doesn't have a random function. So all I did was I grabbed the time and I do like a division with an incrementing number and grab the modulus from that, and it's not great, but it generates enough of a unique pattern that every time we get a completely different life. So, I mean, this is really cool. We're already on like our third run. It's so much faster. Oh, that's really cool though. I love it. Well, I set out in this episode to experience BASIC on the Centurion, and I very rapidly realized that it is miserable. It's really not good. But it is BASIC, and it ran my BASIC code that runs on just about everything. So if you want to run this same 1D Life BASIC code, I'll put a link in the description below to the source code for that. But also, if you want to see what Centurion programming language is like, I'll put a link in the description below to the source code for the the CPL version of 1D Life that's running right now. It's like I think it's a pretty good programming language, but for any programmers out there, take a look at it and tell me what you think about CPL, because I may be biased because I love the Centurion, and CPL has Centurion in the name. So I want to thank you all so much for hanging out with me today, and I hope to see you in the next one.